All right, here we go. Unit 5 test review. This is the last page. I have about 25 minutes to do it before class starts. So let's see if we can do it. All right. Given all of these ordered pairs, right? I'm just going to go ahead and plot these really quickly. I got 0, 4. Remember, 0 to the left and right, 4 up and down, right? The first ordered pair goes left and right, the second one up and down. So 0, 4 is going to be right about there. -8, -6. I guess I should label these. Here's point A. -8, -6 is right here. We'll call that point B. And then point C is at 2, -4. All right, we really have to be really have to be careful that these are in the right spots. All right, because everything we do is going to be kind of based off of this picture. So if I mess up this picture, that's going to be bad. All right. Find the midpoint of BC. So midpoint, again, I'm not going to write down all these formulas. I've done it, several times in the previous videos. I'm just going to go straight for it. The midpoint of BC, all right? Use point B and use point C. I know that sounds silly, but there are people who are going to mess up their points. All right, so just please be careful when you're doing these things. So the X midpoint is going to be equal to -8 plus 2 divided by 2. -8 plus 2 is -6. Divide that by 2, we get a -3. All right, the Y midpoint, the Y coordinate, I guess I should say. The Y coordinate is -6 plus -4. Divided by 2, that's going to give us -10/2, which is -5. All right, so I'm going to say the midpoint here. Do I have a letter? I'm just going to call it point M. All right, I'm just going to say M is, how about -3, -5. All right. And there we go. That looks like an S, but it's a -5. All right. Find the slope of BC. Again, we're using point B and point C. So I'm going to use a lowercase m. All right. Remember, a lowercase m represents the slope. This is kind of our notation. The slope of BC is equal to, again, not going to write down the formula. It's y2 minus y1. So it's a rise over run. So the y's go on the top in this case. Y2 minus y1 all over x2 minus x1. All right, so -4 plus 6 is -2. All right, 2 plus 8 gives us a 10. So the slope here is -2/10 or -1/5. It's going down one space for every. See, now I made a mistake here. Something doesn't seem right. That should. Oh, that should be a positive number. Why should that be a positive number? Because this is a +2, and then that is a +1. So we have a +1/5. There we go. Yikes. Not a good start to the video. So the slope of BC is +1/5. So it's going up one space for every 5 spaces it goes to the right. Or if you look at BC, it's going up 2 spaces and then to the right 10 spaces. So if you wanted to kind of save a little bit of time here, that's how you would figure that out. So it's your rise over your run. All right. Letter C. Find the equation of the perpendicular bisector to BC. All right, so these problems, they kind of walk us through it. Perpendicular bisector. What we need is we need a perpendicular slope. So here's what I'm going to do. I'm going to write down the perpendicular. Remember, that's our symbol for perpendicular. The perpendicular slope is the opposite reciprocal. So remember, the original slope is 1/5. So that means the opposite reciprocal is -5/1. All right. And now it is a bisector. What is a bisector? Well, a bisector is something that passes through the midpoint. We found the midpoint already. So we have everything we need. They're asking us to do this in point slope form. Well, guess what? We have a point. We have a slope. All right. So we have everything we need. So this one is y minus -5 equals -5. That's our slope. And then x minus -3. All right. And then if we clean this up again, we're going to have y plus 5 equals -5 x plus 3. There you go. That is the point slope form of this equation, and we are finished here. All right, now find the slope of the median from A to BC. All right, so starting at A, going to the midpoint of BC. Well, we found the midpoint. The midpoint was at -3, -5, so right here. All right, so I'm just going to call that, again, we call this point M. Right, that was our midpoint. So the median connects the vertex at point A to, yikes, that looks bad, from the midpoint M, right? So that is the median. They want us to find the slope here. So I know what point M is, right? Point M is, what did I say? I just said it. -3, -5. All right, and then I need point A. Point A is right at the beginning. That was 4 or 0, 4. All right, so find the slope of the median. Just use these 2 points, figure out your slope. All right, so lowercase m, right? So the very first day of this class, I said capital letters and lowercase letters mean different things. This is a good example of it. Capital M is a point. Lowercase m is your slope. And I know they look kind of similar, so kind of just bear with me here. So y2 minus y1 for minus -5 over 0 minus -3. Right? That gives me 9, +9 over +3, which gives me 3 over 1. Right? So the slope of that median is 3 over 1. Now, write the equation of the median in point slope form. All right, so we know the slope here. We said m is 3. Right? We have 2 points on the median, right? Both of these are points on the median. Which one do you want to pick? Really doesn't matter. I'm going to do both of them, actually. So just to show you that it really does not matter. All right, so the first one, I'm going to say y minus -5. I'm going to call that +5. Y plus 5 equals 3. And then we're going to have x plus 3. All right, so that's one possibility. Another possibility would be y minus 4 equals 3 times x minus 0. All right, so either one of those equations would be correct. All right, and let me show you why. Right, from here, we're done. All right, but just to make a point here, I'm gonna solve these for y. I'm gonna say y plus 5 equals 3x plus 9. All right, then I'm going to subtract the 5 over. I'm going to get y equals 3x plus 4. All right, I'm going to do the same thing over here. All right, I'm going to get y minus 4 equals 3x minus 0, and then I'm going to add the 4. So I'm going to get y equals 3x plus 4. All right, so if you look at those 2 things, they are the same exact thing. So either one of these would be correct. I don't care which one you pick. The purple one might be a little bit easier, but it does not matter. All right. So here we go. Last question of the review, I think. Yeah. All right. TRI. Triangle TRI has these coordinates. Again, I'm going to plot these very carefully. So here is point T. And then R is at -1, 3. So here's T. Here's R. And here is I. So pretty small triangle. But that's okay. All right. Determine what kind of triangle it is. So isosceles, equilateral, scalene. That's going to be kind of what we're going for here. So TR. TR is equal to the square root of, this means a distance formula. So I'm not going to write down the formulas here. Let's see here. -3. How about let me start over. TR is the square root of point T and point R. -1 minus 0 squared plus 3 minus 0 squared. All right. If we square root all of that, we end up with -1 squared plus 3 squared. All right. And then we end up square rooting this whole thing. -1 squared is 1, and 3 squared is 9. So this is the square root of 10. All right. If we can break it down, we should try, but square root of 10 does not simplify. So that one is done. All right. Now, so I used point T and point R for that one. The length of RI, same kind of thing. We're going to go 2 minus -1 squared. All right. Plus, we're going to do the same thing with the y values here. 2 minus 3 squared. All right. 2 minus -1 is 3. So we're going to have square root of 3 squared. All right. And then plus we got -1 squared. All right. That is also square root of 10. So just from those two things, we can confirm, hey, this is an isosceles triangle. Just those two alone let us know it's at least isosceles, but we need to check the third one. All right, so that blue was R and I, so the last one is going to be T and I. All right, so we have the square root of, let's see here, x2 minus x1, 2 minus 0 squared, plus another 2 minus 0 squared. So that's kind of nice. All right. That is the square root of, let's see, we got 2 squared plus 2 squared. That's 4 plus 4 is 8. That's the square root of 8, which equals 2 square root of 2. All right. Well, hey, those are not equal to each other. So TRI, we can conclude TR is isosceles. Right? Because only two sides are congruent. All right. And if I want to make a note of that, I can say TR is congruent to, what do we got? RI. All right. And that one is done. That was the last problem on there. So in order to show the triangles, judging them by their lengths, we would have to use the distance formula there. All right. And there are some shortcuts you can take there. You can turn it into the Pythagorean theorem, but the distance formula doesn't take too terribly long. All right. So there you go. That was your Unit 5 test review in its entirety. So good luck on your test, and we'll see you in the next one.